What's a terrifying fact about space? Story 1. Let's talk about Phoenix A. It is the largest black hole ever discovered. Its predecessor for largest was Ton 6118. That black hole's discovery led to a new definition of black holes, ultramassive. So just how big is Phoenix A? It has the mass of 100 billion solar masses, with a Schwarzschild diameter of 367 billion miles, 590.5 billion kilometers. The problem with really big numbers like that is it's hard to have perspective on them. We just can't imagine things that big. But it helps to scale things down and compare sizes to something more earthly. So I ran the numbers. Scaling down our solar system, I started with setting the sun to 3 feet, 9 meters, in diameter. The Earth, scaled down the same percentage, would be about the size of a tiny ball bearing. Scaled down by the same percentage, Phoenix A would have a diameter of approximately 240 miles, 386 kilometers. That is roughly the distance between Boston, Massachusetts, and Philadelphia, Pennsylvania. Story 2. The Great Attractor, which lies about 147 million light-years away, is a mysterious mass that is pulling on everything within about a 500 million light-year distance. What it is, we don't know, but we do know its mass is around 10 quadrillion times more than our Sun. This is hundreds of thousands of times more than the largest ever discovered black hole, or even the most massive galaxy. It is also obscured by the Milky Way galaxy, lying directly in the path of the galactic core, and as such, we have no way to see it directly. We would have to go to the far edge of the galaxy to do so, maybe even further. Story 3. Want to know the reason we haven't been back to the moon in 50 years? First, there isn't much to do there, and it's really expensive. But another reason is due to the solar flares in 1972. In 1972, between the Apollo 16 and Apollo 17 missions, there was a massive solar flare that would have killed the crews if they were in space at the time. There isn't really anything you can do in space about the radiation, and it's kinda hard to predict when it's going to happen, so you just kinda gotta hope for the best. In the end, a major factor interplanetary travel hasn't become more feasible is due to this radiation. Story 4. So perhaps you've seen movies where a spaceship is out in space, in like intergalactic space, like The End of Empire Strikes Back, where they look out upon a galaxy from without. Well, look up into the night sky and find Andromeda. It's there, but it's pretty darn faint. Now everything else you see is stars or the moon, or planets, maybe a shooting star. All those things are in the Milky Way. So if you were in intergalactic space, say halfway between the Milky Way and Andromeda, think about what it would look like. Andromeda would be 4 times as big and bright, which would still be quite faint indeed, and everything else in the sky, as it's part of the Milky Way, would be just as far away and cumulatively about as dim as Andromeda is. That is, it would only be marginally more lit than if you were in a closet with the lights off and the lights off in the room outside. One Chinese keychain LED light from the 90s with your thumb covering it would be 1,000,000,000 times brighter, almost pitch black in every direction. If there were another ship 300 meters off the bow, unless it had marker lights or your ship was shining a spotlight at it, there wouldn't be enough ambient light to see it. Wave your hand in front of your open eyes in the closet, that's what it would look like, just darkness in every direction. All those pics of galaxies you've seen are either paintings or long exposures. To the naked eye, it's just blackness. Story 5. No matter how cool you think it is, no matter how much you want to go, no matter how long or how hard you train to be an astronaut, no matter how much being in space is your dream, you may still have a massive panic attack once you cross out of Earth's atmosphere and hate your time in orbit. Many astronauts experience an overwhelming sense of grief and dread upon looking at actual outer space from a shuttle window. This phenomenon actually ruined the trip to space for William Shatner, who wanted to go to space for decades. Story 6. In a few billion years, if the expansion of the universe keeps on exceeding what is the current theory, any new civilization that is born then will think their galaxy is all they have because the universe will be expanding far beyond the speed of light, so light from distant galaxies will never reach them. Today, we know of the billions of galaxies out there, and we should feel privileged that the space we see today in the sky allows us some magnificent views. Future civilizations won't have that privilege. Heck, they won't even know about it, which is sad. This is actually what terrifies me most about it, that it doesn't really matter if space is infinite or not. The expansion of universe basically makes everything after a specific point invisible and unreachable for us. A theoretically it doesn't exist thing. A huge part of the universe that we know it's there, we know it have thing on it, but we can't see, can't detect, and can't reach. Story 7. There's this thing called the Drake equation, which is used to calculate the number of alien civilizations in the Milky Way galaxy. The exact number is up for debate, but pretty much every space expert agrees there is a really good chance there are tons of aliens out there. This leads to the creation of the Fermi paradox, which asks why we haven't been able to find aliens in space if there are so many mathematically calculated to be out there. Source: my professor was an award-winning NASA rocket scientist and would not shut up about this. Maybe because those mathematical equations still don't account for many variables that even we don't know are required to form intelligent life. Life starting from scratch requires a perfect set of things to happen, which might be too hard to replicate elsewhere maybe. Again, that doesn't mean it didn't happen. It took nearly 4 billion years just to get from life to intelligent life here, so you never know which stages life is at outside. Or maybe we're literally the first ones, and maybe future civilizations aren't even born yet. The universe is 13 billion years old, which might sound a lot, but it is still in its infancy compared to the time left. The initial many billion years, in fact, were a chaotic time for stars to exist, let alone life on planets around it. It isn't far-fetched to assume there might not be much intelligent life out there still, or we might actually be one of the first, if not the first. Another sad hypothesis is that space travel for organic materials is just too hard. Even if somehow someone decodes near-light speed travel, a single small pebble rolling around in space can become a deadly bomb if you encounter it at those speeds. So maybe intelligent civilization just stopped trying and are probably more invested in creating virtual worlds to suspend themselves. Think Matrix. Story 8. It's expanding in every direction all at once at large scales, and that compounds with distance, meaning very distant objects are moving away from us faster than the speed of light. This means anything over a certain distance, the observable universe, we will never be able to observe. But it's more than just about light, it's about causality. Since light speed is actually the fastest speed where information can be communicated, two objects moving apart faster than light might as well not exist to one another. There is no way one could ever interact with or affect the other. Now let's get even scarier. This rate of universal expansion is actually increasing. Over very long time scales, the sky will become darker and more sparse as extragalactic objects move beyond the boundary of the observable universe relative to us. Compounding this with the end of star formation in our own galaxy, the existing ones will burn themselves out until there is absolutely nothing left in the night sky. It will be totally and completely black. Well, to clarify, humans, the Earth and the Sun, will be long dead by then, so there will be no one left to observe this. Eventually, the entire universe's space will be so stretched out, and matter so degenerate, that any particle in it cannot possibly interact with any other particle in it, and thus, things stop happening. No more history of anything, no particle interactions, just isolated particles chilling at their lowest energy state, unable to get within range of another to accomplish anything. Time will cease to have meaning, because absolutely nothing can happen. Now that's beautiful, and utterly terrifying. Story 9. When we conceptualize space, we typically limit ourselves and think laterally, in the way we think of wide open spaces and directions on Earth. We extend this thinking beyond the plane in which the Earth orbits the Sun and imagine some distant galaxy way, way over there, laterally, and think, wow, that's really, really far away. But with regard to space, that plane and our conventions of up and down are arbitrary, and the universe is vast in all directions, up and down from Earth's poles, as well as beyond the plane of Earth's orbit. Whenever you stare into the night sky, imagine the Earth as a lifeboat, and you are looking over the side of the boat and down into the depths of an ocean flecked with suspended stars and galaxies, and you thought the Pacific Ocean was deep. Story 10. That the universe we live now, where there are galaxies, stars, planets, is basically a tiny percentage of the universe's actual life. That, if current theories are correct, the vast majority of the universe's life will be black holes and scattered matter flying around with no light, no energy, etc. And even then, it might end, and our universe will be in perfect harmony, with energy evenly distributed by the whole universe, where nothing happens, and it keeps not happening forever. It is really weird to even think about it. Story 11. I don't know about terrifying, but Prof. Brian Cox did a very good job of breaking down just how unlikely it is that we will ever meet alien races, which boils down to how unlikely it is a civilization like ours can evolve to the point we are at, being able to calculate our place in the universe and understand it. All multicellular life on Earth evolved from one single encounter between two single-celled life forms, where one absorbed the other, but instead of being digested, they formed a symbiotic relationship with the inner cell, releasing energy that meant the outer cell could freely evolve. The inner cell is now our mitochondria. There was single-celled life on Earth for 4 billion years before this one chance meeting of two cells, called the fateful encounter hypothesis, and all multicellular life forms are descended from it, whether it's grass, elk, or toadstools. There are likely billions of planets that can and do support cellular life in the universe, but this fateful encounter seems to show that multicellular life like ours is vanishingly rare, added in the conditions needed to allow life to evolve to our point of civilization: the right electromagnetic field, having a tidal moon, having a gas giant like Jupiter to draw away dangerous asteroid strikes, etc., etc. Basically, it boils down to, no, we aren't going to be visited by aliens, because the likelihood of another civilization evolving from vanishingly unlikely natural odds, than being in the same cosmic time window as us, let alone within visiting distance, is as close to zero as probability allows. Story 12. The Buddhist Void. It has a radius of around 62 megaparsecs, roughly 330 million light-years across, and contains 16 or so galaxies. It is so empty, it is theorized if you lived in the center, you would see very little of anything due to the sheer size. It is theorized that light from the surrounding galactic superclusters may be very limited. Originally, it was unclear how it formed, as the size of the void technically would indicate it took longer than the age of the universe to form. Now, it is believed to have formed by multiple voids merging, similar to how multiple soap bubbles can merge into one large bubble. Story 13. It is a common misconception that astronauts in orbit are weightless because they have flown high enough above the atmosphere to escape the Earth's gravity. In fact, at an altitude of 400 kilometers, 250 miles, equivalent to a typical orbit of the ISS, gravity is still nearly 90% as strong as at the Earth's surface, and anything at that height not orbiting would plummet back down to Earth. Weightlessness actually occurs because orbiting objects are in freefall. If you imagine a cannonball shooting out of a cannon, you will see its trajectory form an arc, and the faster that cannonball gets shot out, the larger that arc becomes. So if the cannonball was to be shot out fast enough, its curving arc would match the curvature of the Earth, and this is what we call orbiting. Fortunately, at the height of the ISS and space shuttle, There is no atmosphere to slow that orbit down, and so it's a good height to keep them up there. Story 14. What always freaked me out is the idea that if you were in a spacesuit doing a spacewalk and became untethered fast and began drafting into open space, there is literally not one thing anyone can do to help. You will spend the rest of your life consciously flying into the abyss, dehydrating, starving, or freezing to death. Lots of time to think about your life in the cold, empty silence. You would also not drift fast enough to get away from Earth, so you would slowly drift further away from home and just have to watch the planet survive without you. Story 15. It's the thought of going back to where you were. When you lose someone and you think, if I could just go back, it's the realization of how far you actually are from that point in time and space. In the 30 seconds, the planet has already traveled miles and rotated, and the solar system itself has shifted. It's the thought of how far I actually am away from someone who died. It would be like falling overboard on a cruise ship in the middle of the night, in the middle of the ocean, and watching those lights fade into the distance. You have to realize sometimes how precious now really is, even though it never ends. It's f***ed up. Story 16. It's not still. Things are not just floating there in space. Everything is moving around at astounding speeds, and it's all leaving a wake behind it too, of debris and weird solar winds and maybe other disturbances that we barely know anything about. So space is more like the open ocean, but nothing is anchored to anything. Everything is always moving around, creating huge wakes behind them. Our entire solar system moves as a unit while rotating around our sun at the same time. So imagine traveling to another solar system. We first have to leave this hurtling ball of planets, fire, and rocks, and then try and hit another equally hurtling ball of planets, fire, and rocks. Story 17. That when you're in space, you can't escape your craft without another. It isn't like a boat where you can swim. If you're stuck, you're going to die on the ship. You are not floating to safety. Even around a lush, oxygen-rich planet like Earth, you're going to die looking at safety if your craft fails. What are you going to do? Jump to the planet? You'll die before you come close to the atmosphere without an EVA suit. Even then, you'll fall to your death, and it will be violent. Story 18. We may have already missed the window to understand how the universe works. Example, most of our understanding of the universe comes not from seeing the stars, but seeing other galaxies. We can understand the size of the visible universe from this. We can measure the rate of expansion of the universe from redshift present in the furthest galaxies. We can see supernovae in other galaxies that help us calibrate our tools. Basically, everything we know about the universe comes from being able to see other galaxies. Eventually, the rate of expansion in the universe will be fast enough, and the galaxies so far apart that their light will no longer be capable of reaching us, and most of the lights in the sky will wink out, never to be seen again. Any life culture that evolves after that point will never know other galaxies exist. The galaxy they are in will be the limit of creation, because it will be all that they can ever see, no matter how hard they try or how advanced their technology gets. Their window for understanding the universe will have closed, and it's entirely possible such a window for understanding the true nature of the universe has already closed for us. That something, and we have no way of knowing what, may have already passed the point of no return, and we will never, ever understand the universe because of it. No matter how good our technology gets, no matter how smart we become, it may simply already be too late. Story 19. This may be either terrifying or comforting, but nonetheless, everyone hears about how old the universe is, 13.7 billion years, but no one ever talks about how old it's projected to become. The predicted ages of the universe are divided into 5 different periods. The primordial era, Big Bang end stuff. The stelliferous era, stars and galaxies end stuff. The degenerate era, that stuff starts to break down. The black hole era, self-explanatory, lots of stuff reduced to black holes. And finally, the dark era, everything kinda decays, gets inactive, and turns into a void. As you may have guessed, we're currently in the stelliferous era. So how long will this last? Maybe a few more billion years? 5 billion? 10 billion? 20? Nope. Top estimates say 100 trillion years. So, using this estimate, if the entirety of the stelliferous era was a year long, we'd be barely an hour in, including the brief primordial era beforehand, 100K years. And this doesn't even account for the absurdly long eras to follow. Long story short, yes, the universe is insanely old, and that's scary. But how old is it going to be? Messes with your mind even more. Story 20. It either contains other intelligent life forms or it doesn't. Both are equally terrifying. The more I hear this quote, the more I hate it. I don't find the idea of intelligent life out there remotely as terrifying as the idea that we're the only one. I find comfort in the notion that life pops up wherever it can, intelligent or otherwise. If the universe is entirely devoid of life except this one place where it flourished, that would be pretty solid evidence in my entirely atheist book for a creator god, which, yeah, spooks the hell out of me. I don't believe for a second that we're the only intelligent life in the entire universe. The idea that the dice can't fall roughly the same way twice is blatant nonsense. I mean, sure, technically possible, but it's a really staggeringly vast universe. There must be more times where the right conditions arose, and life evolved and developed intelligence. I readily believe that life in forms we'd recognize is outright commonplace in the universe, and intelligent life is less common, but shows up from time to time. Maybe we'll never know for sure, but it seems intuitively obvious to me that the universe is teeming with organic life, much like we find on Earth. Story 21. Not exactly a fact, but I think about this all the time. The universe is a dark forest. Every civilization is an armed hunter stalking through the trees like a ghost, gently pushing aside branches that block the path and trying to tread without sound. Even breathing is done with care. The hunter has to be careful, because everywhere in the forest are stealthy hunters like him. If he finds another life, another hunter, angel, or a demon, a delicate infant to a tottering old man, a fairy or demigod, there's only one thing he can do: open fire and eliminate them. Story 22. There are many ways for the universe to end, two of which are likely. First scenario is where the universe continues to expand while still increasing in speed. Eventually, it will be fast enough to overcome the gravity holding galaxies together, then solar systems together, then faster than light, nothing will be able to interact with each other, and all will end in the scenario known as the Big Rip. Another way the universe will end is that as the universe expands, there will be more and more dark matter, and gravity will overpower the expansion of the universe, having everything going to one point and collapsing into nothing, ending in the Big Crunch. Story 23. It is the sheer scale of space that gets me. There are places we can see with our telescopes that if we launched a ship today that could go the speed of light, they would likely be overtaken by a more evolved species of human before they arrived. We couldn't even fly to the edge of our own galaxy because it is so vast. We see other galaxies with their billions of stars, and they look dense and like you could zip from star to star, discovering solar systems and planets, but you can't. Each individual star could take from decades to thousands of years to travel between. If you want to put a Star Trek twist on it, the Enterprise D, Next Generation Era, could just about squeeze warp 9.9 for limited time, which is supposedly over 3,000 times the speed of light. But the entire Federation has only explored less than 20% of our own galaxy and has never been outside. It could still take weeks and months to travel places at that speed. Story 24. If you overlay the universe and the brain's neural mapping, they align almost perfectly. In a way, our brain is a universe of its own. Something that makes no sense to me is the fact that our universe could theoretically have occurred billions of times in an ever-repeating cycle of entropy. In the grand sum of things, Our existence is basically meaningless. Even if you cure cancer, end world hunger, or win the Nobel Prize, you are not going to be remembered. We are so astronomically insignificant that the only thing which can be said to be significant about our existence is the fact that we experience it. Story 25. There's no sound in space. The crazy vastness of the universe, the probability of other sentient life that may even be 100 times smarter than us, is actually cool for the curious mind. The astrophysics things can't truly scare me because I understand very little of them. But complete and utter silence of space scares the bejesus out of me, right down to the very core. I hate when it becomes too silent in the city at night. I'm terrified at the thought it could be so absolute.